I'm Elysa. I found this AI engineer intern in paper position on LinkedIn. The job description mentions they're looking for someone with Python skills, exposure to LLMs, familiarity with RAG and vector databases, and experience with Fast API and Streamlit. What I built is a mini platform AI with Docker Compose. The stacks include Fast API for the REST API with JWT authentication, Streamlit for the front end, Olama for running local LLMs, ChromoDB as the vector database for RAG, PostgreSQL for persistent storage, Redis for caching, and Nginx as a load balancer, and also Prometheus with Grafana for monitoring. So let's jump to the project. Right, this is the project. We're gonna sign in first. All right, so this is the landing page. On the left side, we have four menus. They are chat, classify, RAG pipeline, and monitor. Also on the right side, we have the model config. You can choose the Tiny Llama, Mistral, and Phi. Also the system prompt where you can adjust how to interact with the AI. And also the session. So I'm gonna try the Mistral here. All right, and here is the answer. What is data analytics? Data analytics is the process of inspecting, cleaning, transforming, and modeling data to discover useful information, blah, blah, blah. All right, it works, guys. So let's try to classify. So the classify menu is for the text classification. They will give you the analyze of the result, whether it's bad or good sentiment. So we're gonna paste the text to analyze here and click on the analyze text. Let's see what happened. In 9.5 milliseconds, the sentiment analysis result is negative with intention written and topic is business. Recent update to the application has been extremely disappointing. With a negative confidence of 82.1 confidence and intent written is 96 confidence and the topic is business with a rate of 69.1 confidence. Here the bar plot you can see. So you can download as a plot PNG here. You can zoom and so on. This is the RG pipeline where you can retrieve augmented generation with 5-phase until the AI give you the grounded AI answers. From knowledge base, embedding, vector search, context injection, and grounded answer. We're gonna try to put the content here and let's see what AI say to us. I'm gonna rename this document name into AI.txt. Alright, this is the document content and click on ingest document phase 1 and 2 documents here. Let's jump to the next phase, which is query and answer. Alright, let's see the energy pipeline, knowledge base, and embedding are done. Now move to the phase 3 until 5, query and answer from the collection default and put your question here. What is AI used for in customer services? I want to choose the V model for this one and search generate answer. Let's see what the AI says. AI is used in customer service to automate responses and provide quick answers to frequently blah blah blah. So the answer of this will base from the document we gave to the AI before. So this is what we called RAG pipeline. Alright, it works, and this is the documents to store documents we have edited before. Now refresh. Let's see the AI.txt. document we just add before from the default collection, the chance, character, and created. We're gonna try to monitor the last feature of this app. This is for the platform monitoring. We have the total requests from the last 24 hours and average latency, total tokens, error rate, and documents. We have the endpoint by chat, the blue one, the red one is reg or query, orange one classified, and the green one is reg or ingest. We have also the inference logs from the endpoint, model, latency, token status, cache, and time. And also for the advanced monitoring, we have the Grafana dashboard, Prometheus, and API docs connected to the Swagger. And for the Prometheus, you can make the monitoring here by put on the expression formula. And for the Grafana, this is the dashboard that I made yesterday from the monitoring data. Here you can see the monitoring from the last 5 minutes up to the fiscal year and so on. I want to try the last 2 days. Let's see. We have the average latency, also error rate and request rate per second.
Alright, so at this point, I will explain the code to you guys. First, let's start with the Docker compose.yml. This on the fourth line AINet is the network name, so all containers must use this network to communicate with each other via host name. And on the line 5, driver bridge, this is the bridge network type, where all the containers are isolated from the host but can still access to each other. Next, on the line 7, volumes defines the persistent storage. And then the line 13, llama underscore data, is the volume for AI models already downloaded by Llama. Next, we're going to jump to Nginx. This is the reverse proxy, the only container that exposes a port to the public. We use the port 8080. And then on the line 24, this is the read-only. The config file cannot be modified from inside the container. And on the line 13, restart unless stopped means container automatically restarts and crash unless manually stopped. Next, we're going to jump to the fast API. So this is the primary API instance. We use the port 8000. And on the line 41, hostname Postgre, container name, Docker DNS resolves this automatically. And also for this instance ID primary on line 48, this is distinguishes instance 1 versus 2 in logs and responses. And the condition service healthy on line 51. This is the fast API will not start until Postgre passes its health check, prevents crashes when the DB is not ready. For the fast API 2 on the line 59, this is the replica for the load balancing, built from the same Docker file. Look up at the number 72, the instance ID replica. It means the only difference from the primary instance. Nginx uses this one as a backup. We use this container for the front end or the UI. We use the port 8000 on line 91. Next, we move to the Llama. Here I use the Llama for the local LLM container. And for the line 105, Llama data root Llama is For the downloaded models are stored in the volume, no need to re-download on restart. For the entry point on line 110 here, this is overrides the default entry point to run two commands at once. And for the sleep 5 here, it means it will wait for 5 seconds until the server is ready to accept commands. And the Olama Pool Tiny Llama, this is the downloaded Tiny Llama model. Skip if already present in the volume. Next, we have the Postgre here. So look at line 122. SQL files in this folder are automatically executed when the database is first created. And for the line 126, the health check, the Docker checks whether Postgre is true already, not just running. On the next line, on the line 127, the test is for checks whether Postgre can accept connections. And on the line 130, the retries 5, it means retries up to 5 times. If it's still falling, the container is marked unhealthy. At line 136, the commodity server apparently yes. It means writes ever change to disk or persistence mode, and the max memory here limits Redis RAM usage to a maximum of 512 megabytes. And the max memory policy here, when RAM is full, affix the least recently used keys. But now we move to the main.python on the Face API app. Look at the line number 2 to import struct. This is the structured login library. JSON output is yet to freeze by Prometheus or Grafana. Next, look at the line number 6. From Prometheus Face API, this is automatically exposes metrics for all endpoints at or metrics with no extra code. Alright, on the number 17, the async def. This function runs on app startup and shutdown. And then for the await create tables, on line 19 creates all DB tables if they do not exist. Line number 20, await init Redis. Opens the Redis connection. If Redis is down, the app keeps running. Running only. And for the line number 21, the yield, this point where the app runs normally, code after yield executes on shutdown. Now let's see at the line number 28, the lifespan here. This is registers the lifespan handler defined above. And here for the line 33, app.add middleware, cross middleware, allows browsers from the other domains to access this API. Let's look at the line number 35, this instrumentator here. Okay, this is injects Prometheus counters or histograms into every road automatically, while this .expose here creates the get matrix endpoint that Prometheus can create. And the line number 38 here, this middleware executes for every incoming request, while the number 40, start time, records the start time before the request is processed. Line number 41, the response await. This is forwards the request to the matching handler and awaits the response. Look at the line for number 43, is MS round. Here, this is the duration in milliseconds, useful for detecting slow endpoints. So let's take a look at line 48 up to 51 here. So this is the root registration. Line number 48 is for the login and register, and line 49 is for the chat with LLM. Meanwhile, the line number 50 is for the text classification, and line number 51 is for the RAG pipeline.